here we have a circle with its center at the point O and a triangle ABC, a tangent AT in such a way that this AT and BC are parallel to one another. What we need to prove is that ABC is an isosceles triangle. Now here we are given a very interesting hint. You see this line in between passing through O. If we can name this point, say M, all we have to do is prove that these two small triangles, instead of taking the big triangle, we can prove that these two small triangles are congruent. Is that possible? What do we know? At the point of contact here, at the point of contact, the radius and the tangent are perpendicular to one another, which means OA and AT are perpendicular, which means this whole thing is what? 90 degrees. But then what do we know? AT and BC are parallel to one another, and think of AM as a transversal. Then what do we have? This angle here and this angle here are what? They are co-interior angles, which means what? They are supplementary. So that means if this angle is 90, this angle here is also 90. But then what do you see? BC here is a straight line, which means what? The whole of this angle DMC, this whole angle will be 180 degrees, which means if this is 90 degrees, this will also be 90 degrees because it is a straight line. So when you consider these two triangles, what do you see? A right angle here, a right angle here, both are right angles. Then a common side AM, that is also done. We just need one more side or one more angle. Is that possible? Now you see this, the perpendicular line from the center. What does it do? It bisects a chord. This is a result that we have studied in our earlier classes. If we have a line from the center to a chord, then if it is perpendicular, it will bisect. If it bisects, it will be perpendicular. You just need one of these results. Either this line should be perpendicular or it should bisect. Any one means the another. What do we have here? We have a line from the center to the chord which is perpendicular, which means what? It will also bisect. Now three conditions are satisfied, one angle and two sides we have. But tell me which congruency is going to help us. Usually whenever the children see the right angle, they just jump to the conclusion that it is going to be RHS. Is it RHS? What does it mean? Do you have a right angle? Yes. But do you have the hypotenuse? No, you don't. You cannot apply the RHS here because you do not know anything about the hypotenuse. Then what will you apply? A side, an angle in the between, and another side. What do you have? Two sides and an angle in between is SAS. So when you write the congruency, be very careful. So these two triangles are what? They are congruent. Then by CPCT, what do we have? AB and AC are equal to one another, which means what? ABC is a isosceles triangle. That's all for today. Assalamu alaikum.